Hi class, today I will be talking to you about the formation of blood components and the effects that occurs with them at high altitudes. For a short overview of this topic, I will first be talking about hematopoiesis, the formation of blood components, and in particular the erythrocytes, which I will dive into pretty deep today. Secondly, erythropoietin, a hormone that stimulates red blood cell production, is the second topic. Hematocrit, thirdly, will measure our red blood cell percentages, our level of red blood cells compared to the rest of blood. And also, I will talk about the risks of being in high altitude and what that does to our blood cells and blood composition. So first, hematopoiesis, as I said, is the formation of formed elements within the blood, like the erythrocytes, leukocytes, and platelets. Here we see the lineage of all of this makeup of cells within the blood. The first originating cell is the hematopoietic stem cell. This divides into two different lines, the lymphoid and myeloid stem cells. The lymphoid will give rise to different lymphocytes, and the myeloid stem cell gives rise to other leukocytes, in particular the granulocytes and monocytes, and also gives rise to the platelets, but most importantly for the topic today, it gives rise to erythrocytes. Next, I'll talk about the red bone marrow. The red bone marrow is the location for hematopoiesis, where all these blood cells are formed. This occurs in the red bone marrow is in the spongy bone, which is in proximal ends of long bones and other flat bones as well. So basically, the blood cells are created here and transported to the blood from vessels that transport these cells there. These cells are developed mostly within the bone marrow, but also transport into the blood prematurely. They are not fully mature yet. For example, erythrocytes can leave as reticulocytes, where they further mature within the blood. We see this often when there are high amounts of bleeding and we need to get lots of red blood cells back into the blood, and the red blood cells are being produced rapidly, so they will be shot out into the blood in a more premature form where they then mature. Erythrocytes, this is also red blood cells, as I've gone over. These are formed from erythropoiesis, the formation of red blood cells. As you can see in the figure, they have a specific characteristic that we notice, the biconcave shape. It allows for easy maneuver through the blood vessels. Also, this biconcave shape gives rise to more surface area for molecules like hemoglobin to reside within the red blood cell. And the more hemoglobin we can contain in a red blood cell, the more oxygen that can be transported, which obviously helps bringing more oxygen to tissues and organs that we need. Next is erythropoietin. This is a very important hormone in regards to the topic today. This hormone mainly resides within the kidneys and liver, where it is stimulated and goes to these long bones and flat bones where the bone marrow is. And this is it's first stimulated because of mainly hypoxemia, where there is inadequate oxygen transport within the blood. So once it reaches the red bone marrow, erythropoiesis is heightened and increases the red blood cell count. this increases oxygen transport because there are more red blood cells within the blood. So this can counter blood loss when, like I said, we are losing lots of blood cells. This needs to be stimulated even more and create more red blood cells so that we can get the blood cells out there transporting more oxygen. Generally, this is stimulated as a result of hypoxemia, which is basically low levels of oxygen in the blood, and anemia, which I will dive into further later. Hematocrit is defined as the packed cell volume. This is basically the percentage of erythrocytes in comparison to the total blood volume. In men is about 42 to 52% erythrocytes, and women 37 to 48%. In the figure here, we see a sample of blood being taken and put in the centrifuge, and the centrifuge is spun at a high speed as to separate all the different blood components. The red blood cells being the most dense, sinking to the bottom, and this is about 45% of the total blood, the red blood cells. So you can see that compared to 1% of only leukocytes and platelets, erythrocytes are a lot more abundant, make up much more of the blood. We use this measurement to measure or determine oxygen capacity that can be carried within the blood, and also erythropoietin will react accordingly with the amounts of red blood cells that we see in the hematocrit. Next is blood viscosity. Blood viscosity is basically determined by red blood cell count. It determines whether the blood is going to travel sluggishly or more turbulent. This viscosity is determined by the red blood cell concentration, not the leukocytes or platelets, because there's only about 1% of leukocytes and platelets in the blood, as I mentioned earlier, as opposed to the 45% of erythrocytes. In the figure, we see a turbulent blood flow that kind of bounces off the walls of the arteries and can scar it, and also lead to plaque buildup, which leads to further complications within the blood. So we need the blood to keep a constant viscosity throughout. Now I'll talk about life at high altitude. Oxygen percentages at high altitude decrease significantly as elevation increases. Here I listed the level at sea level, which is about 21% of oxygen that we can take in. And I provided a kind of drastic example, but one we need to recognize. Mount Everest, at base camp there's only 11%. Base camp is about 17,000 feet above sea level, so a drastic change in oxygen levels. And the summit is only 7% oxygen that we can take in, so generally you can only stay up there for minutes at a time and must retreat down as soon as possible. In regards to acclimation to this higher altitude, we see that people who live at higher altitudes generally have about 7 to 8 million red blood cells per microliter. People who don't live in high altitudes only have about 5 million red blood cells per microliter. And consequences of living at high altitude can result in anemia. This divides into 3 categories, where either just fewer red blood cells are produced or low hemoglobin. There's also anemia from excessive bleeding, and hemolytic anemia, where red blood cells are destroyed. The consequences are basically resulted from hypoxia and hypoxemia. This is low oxygen levels in the blood osmolarity. This can cause liquids to flow out of the blood because there's not enough red blood cells to counteract, and this fills interstitial spaces, causing edema, perhaps. And blood viscosity, as I mentioned earlier, can sort of scar up the arterial walls and cause plaques. To conclude, the body must respond to these rising and falling erythrocyte levels, especially in regards to the environment at high altitudes. And erythropoietin is the key in doing this, because oxygen can decrease. Erythropoietin needs to stimulate red blood cell production. These are my references, and I'd like to thank Dr. Powell, Tiffany, and the Health and Human Science Department here at LMU. Thank you.